Hello there, algebra friends. Hopefully you're having a wonderful day. We are going to do some graphing of our quadratic equations. And I've mentioned this a couple times. You may have heard me say this in passing here and there. A quadratic graph, quadratic function, is also called a parabola. Spelled parabola, but pronounced parabola. So today we are going to graph parabolas. We're going to use our calculator. So if you don't have a calculator, you can get a Desmos app on your phone or go to desmos.com and use that to get a table of values. But we are going to use our calculator to get our table of values and also apply some of the things we did in lesson 1 and 2 where the graphs were given, but now we're going to create our own graphs. Okay, kind of just still mixing it all together. Our first equation, f of x equals x squared plus 4x plus 4, is given in function form, function notation. Let's pick out our a values, b values, and c values. Remember, the generic form, it's called standard form for the quadratic equation, or a quadratic function, is in the form ax squared plus bx plus c. That's how we're going to figure out what number is a. The invisible coefficient in front of an x squared is 1. What number is b? B is always the number that's the coefficient of the x term. So in this case, it is 4. And then c is the number that has no x next to it at all. So that is also a 4. So we are going to use those a lot in our next unit, but they are very important to finding our axis of symmetry when we use the formula x equals negative b divided by 2a. That's why we pick out our a numbers and b numbers. Okay, so we're going to graph this, but we're going to use the calculator. So our equation function is x squared plus 4x plus 4. So I'm going over to my calculator, have it turned on. Remember, I can push the calculator button, get over to our graph. If your graph, for some reason, has a relation or something else other than function notation, you can go to Menu, and then option 3 for graph entry, and then change it back over to option 1, function. And that'll put it in F there. If you don't see your F there, hit tab, and then that should be able to pull up your F function. So our equation was x squared plus 4x plus 4. When we hit enter, it'll give us a picture. I don't have a lot of exact points that I can see off this particular graph, so I'm going to do Control T, and that gives me my table of values. The table of values should show eventually where my vertex is. And I can find the vertex by looking for where the y values converge and then go away from. In other words, what's the middle of my graph? What's the center of the y values? The center of my y values is the point -2, 0. That's the point that I'm going to put in the middle of my table. So back over on my paper, somewhere in the middle of my table, the x value was -2 and the y value was 0. That's my vertex. And I want that in the middle. So now I'm going to go back over to the calculator. Well, actually, I don't need to do that yet. I'm going to fill in my x's. So -2, counting up, -1, and counting up to 0, and counting up to 1. Then I'm going to count backwards, -2, down 1 to -3, down 1 to -4, down 1 to -5. Now those values are the values I'm going to look up on my calculator. So at -5, it's 9. At -4, it's 4. At -3 is 1. -2 is 0. -1 is 1. So 9, 4, -1, I think I did that right. 9, 4, 1, then 0. So this will be positive 1. And then starts counting back up. 1, 4, 9. So I used the calculator to generate a table of values. I'm going to locate the axis of symmetry to use as the x value near the middle of our table. That's what we did. Now, let's graph it. So -2, 0, -1, 1, 0, 4, 1, 9. Remember, because our graph is symmetric right down the middle, I don't really have to count too much. I can just go to my y value dot and go sideways one line past, or go over one line past and up to the next dot, because it's symmetric. Over one line up to the next dot. And there's my parabola. When you connect your dots, try to make it a curve and try to make it kind of curvy at the bottom. Okay. Do not flail the sides out. It shouldn't look like when you connect your dots and you're doing this, when you run out of dots, that doesn't look right. That is not right. Okay. It's a U shape. The sides get steeper. They don't just suddenly flail sideways. Okay. Now, do we know the axis of symmetry? The answer is yes. At least I do. Do you know the axis of symmetry? Remember, the axis of symmetry is a line that goes right down the middle of our graph. It goes through our vertex and uses the same x value. Since we located our vertex on the table, I know that my axis of symmetry is x equals -2. It's the same x value as our vertex. So we really didn't need to do the -b/2a to find it, because it was right there on the table. Because our vertex is the lowest point on the graph, that makes it a minimum. And we knew that before we even graphed it, because the x squared term is positive. When that x squared term is positive, when our a is a positive number, then our vertex is the lowest point on the graph. So our axis of symmetry will help us find the coordinates of the vertex, but because on the table we were able to find a nice convenient whole number vertex point, I really don't need to do any calculation. So our vertex is at the point -2, 0, which we can read right from the graph. So I graphed the vertex. We used the table to get our symmetric points, and we have our picture. But hey, before we move on, it wasn't asked for yet, but can you identify the roots? Yes. Yes, you can. Where are our roots? Our roots are where our graph touches or intersects the x-axis. In this case, our root is at the same point where our vertex is. So that means our root is also at x equals -2. As written as an x-intercept, it would be the coordinate point -2, 0. That's the difference between the roots and the x-intercepts. It's the same x value, it's just written differently. That's all. Okay, so now what we get to do is just practice and try again. Next equation, x squared minus 7x plus 6. All right, let's identify our a, b, and c values. A would be the coefficient of the x squared, so a is 1. B is the number next to the x, so that would be -7. And c is the number at the end that has no x next to it, so this is 6. Is our vertex going to be a maximum or a minimum? Well, we look at the A value to help us decide. If A is positive, then our graph is a U shape facing up, which means the vertex is the lowest point. If A is negative, it's an N shape, in which case it would be a positive. So A is positive. I am A positive that our vertex is the lowest point on the graph. Okay, so let's get a table of values. X squared minus 7x plus 6. So I'm going to go here. If I can get my cursor and double click where my equation was in the table, I can actually just delete the old equation and put the new equation in. So the new equation now is x squared minus subtract 7x plus 6. Enter. Boom, and the table changed, just like I was hoping. And I'm looking for the middle of the y values, so I don't have an exact middle. Look at that. It's somewhere in between -6 and -6, so it's going to be somewhere in between 3 and 4. So that means, before I do too much, I'm going to find the axis of symmetry using my axis of symmetry equation, x equals -b over 2a. All right, so we know that our b value is -7, so we have to subtract -7, and our a value is 1. So subtracting -7 turns it into +7. 2 times 1 is 2. So we could actually use the fraction 7 over 2, or you may recognize that or use your calculator to convert that to a decimal of 3.5. So we want our x value of 3.5. That is our axis of symmetry. So that means our graph is going to be somehow centered perfectly around our axis of symmetry, and we know that it's going to open upward. Now the problem is graphing an x value of 3.5 is not exact science. Okay, so that's not perfect. So what we're going to do is get the y value for our vertex point, so we know exactly where to put this dot. We're going to get that y value by substituting in our x into our equation. So I'm going to take my equation, use my parentheses to show that I'm substituting in 3.5 in for x. So it's 3.5 squared, just like x squared, minus 7 times 3.5, just like minus 7x, and then plus 6. So now I'm going to go over to my calculator, go over to the generic calculator screen, and I'm going to type in 3.5 squared minus 7 times 3.5. I use parentheses instead of the time sign, but it works fine either way. And then plus 6, and then I hit enter. There is the y coordinate for my vertex point, -6.25. So my vertex is at an x value of 3.5 and a y value of -6.25. So let's see, 3.5, 1, 2, 3, 4, 5, 6, a little bit past -6 would be my vertex. All right, so now that I have those things taken care of, I'm going to go back to my calculator, and I know my x values in the middle of my table should be around 3.5, but I'm not going to use decimals in my table. So I'll just make the middle between 3, 4, and then 5, 6, 7, 3, 2, 1. So I'll just go from there. Now I can go over to my calculator, back to my graph, At 0, it's 6. At 1, it's 0. 1 was 0. 2 is -4. 3 is -6. 2 is -4. 3 is -6. 4 was -6. Notice that they start repeating. So 5 is -4. 6 is 0. And 7 is +6. That means that if I have x of 0, it would also be +6. That just gives me another point to help me with a nice accurate picture. All right, so 0, 6, 1, 0, 2, -4, 3, -6, our vertex, 4, -6, 5, -4, 6, 0, and 7, 6. So again, as we graph this, we're trying to make it look like a nice smooth U-shaped curve. To be honest with you, I usually graph from the vertex out to the sides. I think it's easier. But I didn't do too bad. Not too bad. Hands are a little shaky sometimes. That's what I get for being an old man. All right, so there's our graph. Now, what else are we asked to find here? We were asked to find our roots. Okay, so our roots are the x values where our graph crosses the x-axis. So our x values here are at +1 and 6. So x equals 1 and x equals 6. Written as x-intercepts, I use it as a coordinate point, 1, 0, and 6, 0. And don't forget, if I asked you to write the equation in factored form, we can just take the roots that we know, switch the signs. So the +1, that's a root, becomes x subtract 1 minus 1 in the factor parentheses. And then +6 becomes x minus 6 in the factor parentheses. If they ask for it, that's what we could do with those. All right, so we're almost 18 minutes into the video. We've gone through a couple different examples. Why don't you pause the video, try this next example, and then come back and hit play, and it'll magically all pop up, and then you can pause it and check your answers, okay? So pause the video, try this one on your own, and then when you're done, hit play again, and then we'll check and see how you did. And voila, here we go. So hopefully you had your A value of -1, your B value of +2, and your C value of -1. Since A is negative, our graph is going to open downwards. And since it opens downwards, our vertex is a maximum point. Now, when we looked at the table of values, our vertex is in the table, whole numbers, which saves us from having to find the axis of symmetry algebraically on our own. We can just use the x coordinate from our vertex, x equals 1. And since our vertex is right there, we know the coordinate point for our vertex is the point 1, 0. So I graphed that. I graphed the points from the table. I have a nice upside down parabola, opens downwards. And then I picked out my roots off the graph. My root has an x value of 1, x equals 1, which as an x-intercept, as a coordinate point, is the point 1, 0. Now, off to the side, what's the y-intercept? Our y-intercept is where the graph crosses the y-axis. That would be 0, -1. That would be our y-intercept right over here. Sometimes they ask for the y-intercept, so I just thought maybe I'd go through it with you real quick. No big deal. That's where you find it. Okay, here's another one. This one is already given in factored form. So to pick out our A values, B values, and C values to figure out if it's a max or a min, we have to put our equation into standard form first. How do we do that? Well, It's actually pretty easy. There's two ways. There's the fast way and then there's the long way. The long way is to use the box method that we did back in September and take our factors of x and minus 3 and then x and minus 7, do the box method, multiply it out, and figure out your equation in standard form. Option dos. Using our skills from our factoring units, remember that when we had our equation or our expression, we were looking for two numbers that multiply to be c and add up to be the middle number b. And we would come up with two numbers that we put in our parentheses. Well, now let's do that the other way. When we multiply this out, x times x is x squared. The two numbers, -3 and -7, they add to be the middle number, and they multiply to be the last number. So we can do that box method, or just do it in our head. What's -3 plus -7? That would be the same thing as saying -3 minus 7 more. That's -10x. So our two numbers add to the middle, -10. And then our two numbers multiply, -3 times -7, multiply to be the last number. So there is our equation, our function in standard form. Now that we look at our function in standard form, we can tell that our a value is 1, b value is -10, and c value is 21. Now that we know that a is positive, that means our graph will be a U-shaped graph. So it's going to open upward, making our vertex the lowest point on the graph. Okay, from here, I want you to pause it, finish the rest of this question, and then come back and we'll see how you did. So pause it, try it, and then come back. And here we are back again. So another nice, neat example where our vertex is right in the table of values, saving us a ton of work, because if I see the vertex right in the table of values, then I know my axis of symmetry is that x value, x equals 5, and my vertex is already whole numbers, -5, +5, -4. And then I can graph the points from the table from the calculator, and that works out nice and neat. Pretty sweet. Now, here's a question for you. How would we find the y-intercept of this one? The x-intercepts and the roots are very obvious. The roots are x equals 3 and x equals 7. And our x-intercepts would be the coordinate point 3070. But what about the y? What if we were asked for the y-intercept of this one? Well, here's what we would do. Y-intercept is the value of y when x is equal to 0. So we would take the equation that we have, x squared minus 10x plus 21, y equals x squared minus 10x plus 21, and we would substitute 0 in for the y. So if you're asked to find the y-intercept, you can just plug in 0 in for x and solve for y, and we end up with a y-intercept at positive 21. So if you're asked, that's how you do it. Okay, number 4. No graph this time, but can we find all that fun, great information without a graph? And the answer is, of course we can. We've been doing it all lesson. So what we do first, pick out our a values. A is positive. That means our graph will open upwards and our vertex is the lowest point on the graph. When a is positive, our graph has a minimum. The b is -3 and the c is -4. Okay, so what I want you to do, just like we did with the last couple, pause the video, answer the questions, turn it back on, and we'll see how you did. So with this one, before we get too far, it's important to make sure we're doing our table, doing all right with our table. As if you were watching, you just saw that I started filling in numbers and realized, wait a minute, something's a little screwy here. So I went back and checked things. So what happens here is we do not see our exact vertex in the table, which is a great way to sign off on our lesson. So in order to find our axis of symmetry and get our exact vertex, we have to use our formula, x equals negative b divided by 2a. Since we have our a, b, and c values already picked out, this won't be too bad to do. So x equals negate the b value over 2 times the a value. So negative 3 turns into positive 3. 2 times 1 is 2. So we get our axis of symmetry at x equals 3 over 2. As a decimal, that's 1.5. Okay, so our axis of symmetry equation is x equals 1.5. Now, to find our vertex, we are going to take that value of 1.5 and plug it into our function. So we're going to find f of 1.5. We'll do 1.5 squared minus 3 times 1.5, and then minus 4. So go to your calculator, type that in. When you're done, come back and I'll tell you if you did it right. This is going to give us a y value of negative 6.25, giving us a vertex for our parabola at an x value of positive 1.5 and the y value at negative 6.25. Okay, so then how do I figure out the roots if we don't have a graph? Well, if we don't have a graph, then the next best thing we're going to look for is our table of values, and we're looking for our roots. The roots come when y is 0. So our roots are at an x value of negative 1 and an x value of positive 4, because those are the x's when y is 0. As intercepts, we write them as coordinate points, negative 1, 0, and 4, 0. Now, if we wanted to find the y-intercept here, what we would have to do is take our roots to write the equation. Or no, I forgot. We were given an equation. Well, geez, this will be easy. We can find our roots right now. Or, I'm sorry, the y-intercept. So our y-intercept, since I asked, so our y-intercept is our y value when x is 0. So we're going to take our equation, x squared minus 3x minus 4, x squared minus 3x minus 4. So our y-intercept will be at negative 4. As a coordinate point, it'd be 0, negative 4. So if we're asked to find the y-intercept, put 0 in for x, figure out the y. Now, could we find that from the table? Of course we could. Find the value of y when x is 0. There's your y-intercept right there on the table. Man, if I had only thought of that sooner, I wouldn't have had to done that fun little algebra step. But luckily it wasn't so bad. And we got all the practice problems done in less than a half hour, so it's shorter than a normal class. I would like you to go to your homework, try a couple of those examples. There's 4 graphs there. I would like you to do at least 2 out of the 4, please. You can choose whichever ones you want, but do 2 out of the 4. Shouldn't take you too long, and it's good practice for you to make sure you're getting ready for your checkpoint, which is going to be on in 2 days. So checkpoint coming up. Follow your calendar. And you know what, guys? Have a wonderful break. Now, when you do your lesson tomorrow, which is practice and review, I will make a short little video just to go through 1 or 2 problems if you need it. All right. So I'll see you then. Talk to you soon. Bye-bye.